So my copy is visible.
Yes, sir.
Okay. So let us take another problem like this. Problem says we have some jobs and we have some machines, right? The job one, J1, J2, J3, and J4. And we have machine M1, M2, M3, and M4. And the values are 5, 7, 1, 6, 11, 6, 8, 5, 9, 6, 4, 7, 10, 4, 7, 10, 7, 4, 10, 4, 8, 3. Okay. So this is again an assignment problem. And what we want to solve this problem. Okay. So what was our first step to solve this problem? So basically what earlier you have done, consider the consider smallest element from each row. And look, if someone is waiting in the lobby, just allow them the smallest element from each row and subtract it from other element of that row. So that was what we have done. So first step, so same thing we'll do over here. So when values are now J1, J2, J3, J4, M1, M2, M3, M. If you look at the table, just wait for a minute. So if you look at this table, you can able to see the minimum value from row 1 is 5, right? So whenever I subtract it, that gives me 0, 2, 6, 1, right? 0, 2, 6, 1. And the minimum is 5 again. So that gives me 3, 0, 4, and 1, right? So minimum element from uh, J3 is 4. So if I subtract it, I got 0, 3, then 6, then 3. Right? And now from the last row, the minimum element is 3. So simply that gives me 7, 1, then 8, 5, then 0. Okay, so that is the converted matrix, right? So this was the previous matrix. Let's do it for a minute. So this was the last matrix. And when I used consider the smallest element from each row and subtract it from the other element of that row, then we got this thing. Next step is to convert. What I will do, I will try to find out the minimum element from each column, right? Minimum element doing the same thing, doing the same for column. What I got it like J1, J2, J3, and J4. M1, M2, M3, M
স্যার শোনা যাচ্ছে না, মিউট হয়ে গিয়েছে।
So from when you can able to, you are not able to hear, able to hear. কতক্ষণ থেকে শুনতে পাচ্ছেন? হ্যালো?
ওই তো ওই লাইনটা না, ওই লাইনটা না।
Okay. So as per the optimality condition, you know what? As per the optimality condition, you know that we need 4 lines to cover the zeros to satisfy the optimality condition, right? But here we can able to see we need minimum 3 lines to cover all the zeros, right? So optimality condition is not satisfied. Understand my point? So I got only 3 lines. So this is the line, 2 zeros are covered, then 2 zeros are covered, 2 lines, and in 1 zero left. So I can cover it by this way, or I can cover it by this way. I am covering it by this way. Yeah. Okay now. So what I got it like 3 lines. We need 3 lines. We got 3 lines and cover all the zeros. So optimality condition is not satisfied. Condition is not satisfied. So then we have to do something. Okay now. So if the optimality condition is not satisfied, what I will do? So I told you this is more than kind of like what, like of algorithm, right? So as it is more than like kind of algorithm. So if this condition is not satisfied, we have to do one thing. We will try to find minimum value from all the uncovered values. Now look at this table. So look at the lines which are covered. So uncovered element is 2, 2, 3, 2, 1, 1. So what is the minimum element out of this 1, 2, 3, 4, 5, 6 element? So 1 is the minimum value from here, right? Understand? So 1 is the minimum value here. So the minimum value. Now, after finding this minimum value, we will do 2 things. So first, subtract minimum value from the uncovered values. Subtract minimum value from the uncovered values. Okay, so uncovered values means this 2, 2, 3, 2, 1, 1. So these 6 are uncovered actual element over there, right? Understand? So 2, 2, 3, 2, 1, 1. At the point of intersection. Point of intersection means you can see whenever I covered it by line, 2 lines. So this is one line, this is another line, and this is another line. So point of intersection means 2 lines meet. So 2 lines meet in this position and this position. So 2 lines meets in this position and this position, 2 lines meet. So these are point of intersection. Okay now. So add minimum value at the point of intersection and other covered element remains same. Remains same means, so other covered element is 0 is a covered element, but it is not a point of intersection. 0 is a covered element, but it is not a point of intersection. 7 is a covered element, but it is not a point of intersection. This 0, same thing. This 1, this 3, this 0. All these things will not be changed. So this is the thing. So if optimality condition is not satisfied, then what we have to do? We have to find out the minimum from all the uncovered element. Okay, so that is what I have done. I find out the minimum from all the uncovered element. Then I have to subtract it from all the uncovered element and only add it to the point of intersection. For the other covered element, the value remains same. So the modified table will be looks like this. Modified table will be M1, M2, M3, M4, then J1, J2, J3, and J4. So the modified table will be, look, 1 is the minimum. So first 0. 0 is a covered element, but it is not a point of intersection. So 0 remains 0. Next element is 2. I find out the smallest value is 1. So simply this 2 will become 1. This will become 1. And this 1 is again an covered element, but it is not in point of intersection. So simply it remains 1. Look at the next row. This is point of intersection 3. So 3 will be converted to 3 plus 1, 4. This 0 is a covered element, remains 0. This 0 is a covered element, remains 0. This 1 is a point of intersection, right? So in this case, we have to add 1 with this one. Simply this will become 2. Now, next 0 is a covered element, so 0 remains 0. Next 7 is a covered element, so 7 remains 7. Then 3 is uncovered element, so we'll subtract 1 from it. So we got 2. 2 is an uncovered element. So we will subtract 1 from it and get 1. 1 is uncovered and 1 is uncovered. So this will become 0, this will become 0. And 3 is again covered element, but not a point of intersection, as 0 is also. So now we'll again try to convert them using smallest number of lines, using minimum number of lines. So now you can see we got 3 zeros in this row. So I covered this row first. Then I got 2 zeros over there. So simply I can cover these 2 by like this. Okay now. And then I got another 2 zero like this way. So I then covered this 2 zero by 2 this line. Again you can able to see what I got. I got 3 lines. But what is my requirement? My requirement is 4. So I got 3 lines to cover all the zeros. So again, optimality condition is not satisfied. So again, optimality condition is not satisfied. So in this case, what we will do? We will do the same thing. We will repeat the same step, right? If the optimality condition is not satisfied, we will repeat the same step. Okay. So repeating the same step means, so what is minimum from all the uncovered element? Look here. What is the minimum from all the uncovered element? 1, 1, 1, 2, 1, 3. So these 6 are the uncovered element, right? 1, 1, 1, 2, 1, 3. These are the 6 values which are uncovered, right? So which one is the minimum from here? So 1 is the minimum from here. Understand? Okay now. So 1 is the minimum value from here. And now this 0 is a covered element. This 4 is point of intersection. This 0 is covered and this 7 is point of intersection. So 1 will be added over there. This point of intersection. This is point of intersection and this point of intersection 1 will be added. And for the other values, For the other covered values, that remains same, and uncovered values one will be subtracted. Okay. So if I do it like this way, so what happens? You can able to see. So if I want to write down the matrix again, doing the same thing, what I got. Let me write it: J1, J2, J3, and Z4. M1, M2, M3, and M4. Right. So we'll do the box. So let's go to the previous matrix. So you can able to see. Look at this matrix: 0, 1, 1, 1. So 1 is the smallest element. So if I subtract 1 from this all these values, uncovered elements, so this first row will become 0. And 0 is a covered element, but it is not a point of intersection. So 0 remains 0. Understand? So the value of this become 0, 0, 0, 0. Now, next, if you go here, you can see 4 is a point of intersection, right? If 4 is a point of intersection, so 1 will be added with this 4. So 4 will be converted to 5, and the others are only covered elements, so all of them remain same, right? Look at here, sorry, 0, 0, 0, 0, 2. So this will be converted to 5, and this will be 0, 0, 2. Now, next, this 0 is a covered one, and this 1, 2, 1, 3. So we have to subtract 1 from this. So if I am going to subtract 1 from 2, I got 1. If I subtract 1 from 1, I got 0. If I subtract 1 from 3, I got 2. So simply it will be converted to 0, 1, 0, 2. So it will be converted to 0, 1, 0, 2. Now look at the last one. So if you look at the last one, 7 is the what? 7 is the point of intersection, right? As 7 is the point of intersection, what happened? We'll add one value over there. We will add one value over there. So it will be converted to 8. All the other elements are covered. So if all the other elements are covered, then we have to do nothing with that with them. So it will become 8, 0, 0, and 0. So this will become 8, 0, 0, and 0. Now I will try to cover all my zeros by using minimum number of lines. So now you can see what I got. If I like to cover it like maximum 4 zeros, then 3 zeros, then 2 zeros, then another 2 zeros left. So I need 4 lines to cover all of them. Look at it carefully. So in this case, what happened? Now next step, we will try to cover all the zeros by using minimum number of lines. Right? So you need at least 4 lines to cover all the zeros. You can able to understand that. So what is my target? 4 zeros I want to cover. So this is one covering, right? My minimum number of lines. Now, what I can able to do, if I want to cover another row, another column, I can able to see where 4 zeros are there, right? So if I can cover it like this way, then 3 zeros are there. This and this, it will become more than 4, right? But minimum number of lines required is 4. So this 2, this 3, and this is 4. So we need 4 lines to cover all the zeros, right? So the optimality condition is satisfied now. The condition is satisfied. So what I will do next, I will try to allocate the values. So my next slide is to allocate all the values, right? So assign the values. So now you can able to see. Wait for a minute. Now you can able to see the optimality condition is satisfied. So if the optimality condition is satisfied, you will try to allocate it. So now you can see I'm just going to write down all the zeros, right? J2, J3, and J4. M1, M2, M3, and M4. If I write down all the zeros, only the zeros, so you can able to see 0, 0, 0, 0. This one is 0, this one is 0, this one is 0, this one is 0, again 0, 0. 0. So these are the options, right? So now if you look at here carefully, you can't able to find out any location where only single, any row or any column where single value is there, because I told you this is an one-to-one bijection. So if some work is there, you have to, and some the machines will work. You have to allocate the person to the machine. At the same time, the meaning is same, like machine is allocated to the person, right? So you can check any row or any column. So by looking at any rows or any column, I can able to see no row or no column contains single zero. So the next thing is like this row and this column. Look at this row and this row. This contains two zeros. So I got two options. So let us allocate. So let J2 goes to M2. Okay, so I have two options. Either J can go to M2 or M3. So I just consider that J goes to it goes to M2. So if J2 goes to M2, then this M2 mission is completed. Right? Now, again, what I do have option? I have option like this J3. Let us go for this J3 because all the other have three zeros and these have two zeros. So okay, I can go for these two zeros also. It's up to me. So if I go for J3 and I allocate the value to M1, because I can allocate it to M1 or M3. So I allocate it to M1. So it's got crossed. Right. So now allocated to M4. Now the J1 is allocated to M3, J2 is allocated to M2, J3 is allocated to M1, and J4 is allocated to M4. So this is one of the allocation, right? Now you will think it of like this way that okay, if we are going to change the allocation, then value may be changed. The thing is not like this. If you change your allocation to, still the value will remain same. Okay, so I'm just going to find out two paths and you can check it by yourself. Okay, instead of considering this path, if I start from like J2 goes to M3, sorry, J2 goes to M3, that is also correct. J2 may go to M3, right? Then if J2 goes to M3, then I consider that J3, J3 goes to J3 goes to M1. So I have only one option. J3 goes to M1. Okay. If J3 goes to M1, then what happened? Already I allocated this two. So M1 and M3 is allocated. Now look at here. J4 can work in M2 or J4 can work in M4. And similarly, J1 can work in M2 or J1 can work in M4. So I can allocate a new one to anywhere J1 to M2 and J4 to M4. So this is an array allocation. So if you want to check, you can able to see the total value of this and total value of this will be same. So already you know how to find out the minimum cost required to reach there. Understand? So this is the thing actually. Okay, now. বুঝতে পেরেছিস কি পারিসনি? হ্যালো হ্যালো
এই ছকটা
হ্যালো
আরেকবার, এইটা আরেকবার স্যার।
কোনটা? এইটা
হুম 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 হুম।
অ্যালোকেশনটা দেখ।
হ্যাঁ।
হ্যাঁ, আমার হাতে কি অপশন ছিল? ইন মাই হ্যান্ড হোয়াট অপশন উই ডু হ্যাভ। সো দেখ, প্রথম J1 ক্যান বি অ্যালোকেটেড টু M1, M2, M3, M4, যে কোনো জায়গায় অ্যালোকেট করতে পারি, রাইট? M3, J4 can be allocated to M2, M3, and M4. Understand? So we have multiple options. So what I have done, I allocated first for this first one. I allocated J2 to M2. J2 to M2 means what? I allocated J2 to M2 means the machine M2 is done. So I allocate J2 to M2, that means M2 is done. So these two get crossed, right? So J2 to M2 I find out first. J2 to M2. Next one, I got J3. Now J3 can work for M1, work at M1 or M3. So I have only two options. M2 is filled, but M2 J3 can't able to work in M2, so it is done. So I do what? I allocated J3 to M1. I allocated J3 to M1, right? Once I allocate J3 to M1, so M1 is also done. Gone. So M1 and M2 job has been done by J2 and J3. Now remaining machines are M3 and M4, and remaining jobs are J1 and J2. And J4 also can work in M3 and M4. So what I have done, I just allocate J1 to M3 and J4 to M4. That is what I have done. Understand? বুঝতে পারলি কি পারলি না?
হ্যাঁ স্যার।
Okay. So this is the one thing. This is the one method I want you to understand. So what I will do, I will take one picture later on and I will share it in your WhatsApp group. You can able to see it from there. Okay. And one thing, next thing is like duality. Okay. So that I told you that I will see. So in case of duality, actually, what we have done, look, when this duality theory or this thing comes into the picture, often what happened, in some cases, we got some values like maximization or minimization problem. And let us think it up like this way, that I got a minimization problem, that some value is given there. Just a1x plus a2y plus a3z, right? And subject to conditions are, let's say, 2 with subject to conditions are, let's say, p1x plus p2y plus p3z less than equals to q1, and r1x plus r2y plus r3z less than equals to q2, and x, y, z are greater than or equals to 0. So that type of problem often we got in case of solving the method using simplex method or somewhat, right? So we got some minimization problem and less than equals to condition. Okay, so in that case, what we have to do, we have to convert our minimization problem to the maximization problem. Then we need to solve it, right? But often it will become difficult for us to solve because we have to use here we need to use the simplex method. But if the equations become greater than or equals to, then you have to use some method called pgame method. Like you have to use some artificial variable, right? And the problem becomes bigger. So rather, in this scenario, there is a property called duality property that you can convert this linear programming problem to something else, like dual of this linear programming problem. If you try to find out the dual of this linear programming problem, so in that case, minimization will become maximization. So everything will become opposite, right? Minimization will become maximization, right? And we have to name some two variables. So this q1 and q2 will be come to the objective function. So how it will be q1 w1 plus q2 w2. So if you have w1, so what value you are going to get? See, you can able to if you look here, you can able to understand that I can able to convert this P1, P2, P3, R1, R2, R3. So this matrix will be look like this. So matrix corresponding to this is P1, P2, P3, R1, R2, R3. and this matrix is multiplied by x, y, z. That was the thing, right? So simply we'll take the transpose of this matrix. So if I want to take the transpose of this matrix, what I'm going to get? P1 R1, P2 R2, P3 R3, right? And we have two variables because there are two new variables. Simply we'll write it W1 plus W2, W1 P2 R2 W2, W3 P3 plus R3 W3. Now, if we got less than equals to conditions over there, that will be converted to greater than equals to conditions. And what will be these values? Look at this A1, A2, and A3 that we have not used in the objective function. So this will become A1, A2, and A3. And the condition is like W1, W2 greater than or equals to 0. So now you can able to see this is a maximization problem and we greater than or equals to condition, and this is W1, W is greater than or equals to 3. So this is called dual. This is called dual of the primal. So this problem is said to be the primal. Dual of the primal. Now you can able to understand if I'm going to take again dual of this primal. If I'm going to take dual of this primal will be converted to dual. Look at here. So if I just imagine that I'm going to take the dual of this. So now A1, A2, A3 will come to the objective function. So my variable, let me name it by x1, x1, x2, x3, or x, y, z. Better to write down in the form of x, y, z so that I can get my basic thing back, right? So simply this will be converted to maximization problem converted to minimization problem, minimization of z, right? First thing. Second, this entries will be come to the objective function. That means x1, x plus a2y plus a3z. Understand? So these values will come to the objective function, right? Now we got a matrix like P1R1, P2R2, and P3R3. So the corresponding matrix is P1R1, P2R2, and P3R3. So if I take the transpose, it will give me P1 plus P2 plus P3 R1, R1 plus R2 plus R3. Now the corresponding variables are x, y, and z. Here also the corresponding variables are x, y, and z. And now greater than or equals to conditions will be converted to less than equals to condition. So this greater than equals to condition is converted to less than equals to condition. Now I told you the objective function, variable of the objective function, values of the objective function, values of the objective function are q1 and q2. The coefficient of the objective function that comes over there q1, q2, and we got x, y, z greater than or equals to 0. So you can able to see this should come back to the primal again, right? So dual of dual is called set to the primal. So this is the duality and this is the simplex method, right? And sorry, this is the assignment solution of the assignment problem where you can't able to find out the minimum number of lines. Optimality condition is not satisfied. Understand? So what I will do one thing. I will just take photos of the same what I have done over here and share it in your WhatsApp group, and then I will also share the recording. If you got stuck over there, you can able to check it. So understand this, yes or no? Here is simple.
Yes.
So objective function values, coefficient of the objective function will come to that b. Okay, and coefficient of this b will be converted to go to the objective function. Maximization will be converted to minimization. Minimization will be converted to maximization. Greater than equals to condition will be converted to less than equals to condition. Less than equals to condition will be converted to the greater than equals to condition. So what you have to do, everything is opposite. So every time the thing will be opposite. If it is a minimization problem, you will convert to maximization by using dual. But look here, what we got it. So this problem we need to solve it by using simplex method. But this we don't need to use the simplex method. We can able to solve it by graphical method. So that reduce our effort rate. And one thing you must remember, dual of dual is equals to primer. Right? If you remember this, that will help you to solve dual of dual is primer. Okay. So what I'm doing, I guess this clear what I told you. So just stop recording and I will record the session. I will download the session. I will share it with you. If you got any problem or anything, you can ask me in WhatsApp. Okay. So I will also share the picture of these pages. Right. So thank you. I guess all of you can able to understand it. And happy Diwali to all of you. Okay. Na? Thank you.
Happy Diwali, sir.
Happy Diwali.
স্যার
হ্যাঁ
বলছি যে আজকে যেগুলো করালেন ওটা আর আগের দিন ক্লাসে যেগুলো হয়েছিল এইগুলো মিলিয়ে তো MD2টা হবে।
I can wait for a minute. Let me stop recording. Just wait.